Now we are going to discuss a very important result that is in the form of the Theorem 6.3.1 from the Hogg, McCain and Craig's book. The statement is that assuming that the regularity conditions, these are the conditions which we have already discussed in the maximum likelihood portion, under the null hypothesis, that is theta is equal to theta naught minus log capital delta tends in terms of distribution to chi-square with 1 degree of freedom. That is very important result, and you can see that in many problems, most of the cases, the statistic turns to be the chi-square distribution if we have this type of form. So this theorem is also called the Wilks theorem. So we are going to prove this theorem because this is a very important result and it used in many problems for the application purpose. So how we proceed for this one? Let L of theta, which is actually the log likelihood function, that is log of L of theta, and we expand the function L of theta into the Taylor series about the point theta naught and evaluate at theta hat. So we get that is L theta hat, that is equal to L of theta naught plus theta hat minus theta naught into L dash theta naught plus 1 by 2 theta hat minus theta naught square into L double dash theta naught, and we ignore all the higher terms. We can also write down this one as, because this result will use later on, that is just theta hat minus L of theta naught, इसको इस साइड पे ले जाएंगे. So that is actually theta hat minus theta naught L dash theta naught plus 1 over 2 theta hat minus theta naught square L double dash theta naught. We call it equation 1 and we will use later on. Now define the likelihood ratio, that is capital delta. We just here represent by capital delta, that is L of theta naught over L of theta hat based on the full parameter space. Or we can further write on it like taking log on both sides, so that is actually log of capital delta, and if we take the log of this one, that is actually L of theta over log of L of theta hat, and we represent this by the small L of theta naught, and that is small L of theta hat. So this further can be write down as minus 2 log कैपिटल डेल्टा, दोनों साइड्स हमने इसको मल्टीप्लाई किया तो ये हमारे पास आ जाएगा 2 इंटू एल ऑफ थीटा हैट माइनस एल ऑफ थीटा नॉट. ये डिनोमिनेटर में था, जब ऊपर जाएगा तो ये नेगेटिव हो जाएगा, ये नेगेटिव जब इसके साथ मल्टीप्लाई हो तो ये पॉजिटिव हो जाएगा, और ये पॉजिटिव था तो ये नेगेटिव हो जाएगा. नाउ वी पुट द इक्वेशन 1 इन दिस रिजल्ट, सो वी गेट that is actually 2 theta hat minus theta naught L dash theta naught प्लस हमारे पास 1/2 था, और ये जब 2 उसके साथ मल्टीप्लाई होता है ये कैंसिल आउट हो जाएगा. देन द रेस्ट ऑफ द थिंग्स विल बी दैट इज थीटा हैट माइनस थीटा नॉट स्क्वायर इनटू L डबल डैश थीटा नॉट. थोड़ा सा इसको हम अलजेब्रिकली ऐसे लिख सकते हैं इस टर्म को, दैट इज यू कैन सी दैट 2n के साथ हम मल्टीप्लाई करेंगे, दैट इज -1/2 इसकी पावर लेके, और इसको थोड़ा सा रीअरेंज करेंगे टर्म्स को. सो आल्सो n रेज टू पावर 1/2. तो जब इसके साथ ऐड होंगी तो ये खत्म हो जाएगी टर्म, लेकिन इसको हम इसलिए लिख रहे हैं कि आगे हमने कुछ रिजल्ट्स निकालने हैं. सो दैट इज एक्चुअली थीटा हैट माइनस थीटा नॉट प्लस, सिमिलरली इसके लिए भी हम n रेज टू पावर -1 L डबल डैश थीटा नॉट, और ऐसे हम इसको लिख सकते हैं n रेज टू पावर 1/2 इंटू थीटा हैट माइनस थीटा नॉट होल स्क्वायर. तो ये जब स्क्वायर लेंगे तो ये 1 बन जाएगा और इसके साथ ये कैंसिल आउट हो जाएगा. नाउ वी यूज सम वेल डिफाइंड रिजल्ट्स. वी नो दैट by the law of large number, that is we have already proved in the previous module, that is 1 over n raised to power -1 L double dash theta naught converges to minus I of theta naught, which is the Fisher information matrix. In term of probability, it converges to this one. And we also know that n raised to power -1/2 L dash theta naught, that is also equal to n raised to power 1/2 I of theta naught into theta hat minus theta naught plus Zn, and where Z n actually tends to 0 in term of probability. So if we put all these results to this equation, then we find that -2 log capital delta, that is approximately equal to 2 n raised to power 1/2 I of theta naught into theta hat minus theta naught into n raised to power 1/2 theta hat minus theta naught minus I of theta naught into n into theta hat minus theta naught square. We just only put these results to this equation, and now after simplification we find the result, that is actually equal to 2n I of theta naught into theta hat minus theta naught square minus n I of theta naught into theta hat minus theta naught square, and this is actually equal to n I of theta naught into theta hat minus theta naught square, and this can be written as under root n I of theta naught raised to power 1/2 into theta hat minus theta naught whole square. So we have a result, that is since n I of theta naught raised to power 1/2 and theta hat minus theta naught tends to standard normal in distribution, and its square converges to chi-square with 1 degree of freedom. That is well standard result in term of distribution. So that is actually what we want to prove, that -2 log capital delta, that is actually approximately chi-square with 1 degree of freedom. So From this theorem, we can construct an approximate size alpha test based on the likelihood ratio, capital gamma, without considering the exact sampling distribution. So if we have no sampling distribution, then by using this theorem, if n is large, then minus log capital delta approximately follow the chi-square with 1 degree of freedom when h naught is true. So just need to calculate this quantity and we can easily find the chi-square quantiles for the testing purpose.